Thank you. Well, thank you very much for the organizers for inviting me to share some results with you, and also for, again, producing really a wonderful meeting. I go to a lot of rare disease foundation meetings. This is always one of the best ones. So I'm going to share with you a recently published study that represents an important collaboration between the family's SCN2A Foundation, specifically their clinical trial readiness study that was led by Dr. Ann Berg, and our almost completed NIH-funded Center Without Walls study that performed the functional analysis of every variant represented in this clinical trial cohort. The clinical trial readiness study included 81 participants. Many of you in this room participated in that, and we, of course, are extremely grateful. And of the 81 participants, there were 69 unique SCN2A variants, 50 of which were amenable to doing functional studies, which were conducted completely unaware of the clinical findings of the study. And at the end, we merged together the functional studies with the clinical data so that we had an unbiased assessment of what was the functional effect of variants and their respective clinical picture. The data was maintained in a clinical grade database managed by the Clearings Company and Jerry Nesbitt. So just some summaries from this paper. The primary phenotype in this work was either individuals who had a primary diagnosis of epilepsy and had seizures with an age of onset either in the first month of life, which we categorized as neonatal onset, or infant onset between 1 month and 11 months, or later onset beyond 1 year. And then separately, a group with autism, a diagnosis of autism spectrum, or intellectual disability with or without seizures. Importantly, we used the neonatal onset definition of under 1 month of age, which is distinct from what has been promoted in the literature as under 3 months of age. In our neonatal onset group, all of those individuals had seizures on the first day or second day of life, with one exception, which was someone who had seizures on day 19 of life, but that individual was born 3 weeks prematurely. So we think there's a reason to think that really early onset neonatal seizures is a subgroup by itself. There were also collected in this study non-seizure phenotypes, including gross motor, communication, as you see the list here, eating, ability to use the hand, and also a majority of individuals had a Vineland-3 assessment done remotely by a clinical psychologist graduate student. And so the non-seizure phenotypes were coalesced ultimately into a severity index, which was simply a point scale derived from the occurrence of these non-seizure phenotypes. So we had seizures, yes or no, and what age of onset, plus this global severity index, which was important for assessing non-seizure elements of the severity. So this, again, a summary of who was in the study. There were 81 participants. You can see there was a slight preference for male, but it's almost equal. Median age was about 5 years old, and this was an international study. 69 of those participants had seizures, and they broke down into 27 were neonatal onset, 18 infant onset, and 24 were later onset, and then 12 had a diagnosis of autism. Now, there were many correlations done in this study. I'm just going to show you some of the highlights. The severity index, which was a measure of non-seizure severity, correlated with the Vineland scores, roughly, for different subdomains of the Vineland index. Importantly, this was a cohort of individuals who overall had significant morbidity and severity. And so even for the least severe group, those that had a severity index of 0, even the Vineland scores really represented pretty severe to profound impairment. The other thing that was done uniquely in this study was all the data were considered together, and then using a statistical approach, they were clustered into groups. And so out of that came these 5 groups that I think could almost represent diagnostic categories. So cluster one were those that had mostly later onset seizures with sort of a low non-seizure severity. There was a cluster with, again, mostly later onset epilepsy, but with a high non-seizure severity. And then we have the autism subgroup, and then we have two neonatal onset seizure groups, one with low and the other with high seizure severity. So just keep that in mind. This was a different way of looking at the population at large. We compared that severity score with age of onset of seizures or whether they had autism. You can see that there's quite a distribution of severity among these different groups. If you just look at the neonatal group on the far left, you can see that the non-seizure severity is really quite diverse. So, and that led to this clustering of individuals with either severe, highly severe non-seizure phenotypes or less severe. The variant function, which was my laboratory specialty, we looked at all of these individual variants shown on this map and with their associated diagnosis. It's pretty clear that the distribution of variants is unrelated to the diagnostic category. They're spread all over the place. And then the functional categorization of those variants is shown here. And we categorize variants by these 5 terms. They had severe loss of function, and that included variants that were truncating, loss of function, which were variants for which we could measure the activity of the channel, but it had less than normal function. There were some variants that had a near normal or indistinguishable from normal, which we called wild type like. And then there were some that were gain of function. And then finally, a group that had mixed functional properties. We took a more systematic approach to declaring which category these fell into by looking at 9 different functional properties of every variant. And then we determined for each variant which directionality would we call gain of function versus loss of function, and then we assigned a point value. And then at the end, we aggregated the point scale and then determined and assigned gain of function if the point scale was positive, loss of function if it was negative, and if there was a mixture of functional properties that canceled out and we ended up with 0, then we called it mixed. So here's just a plot, partial plot from the paper showing just this functional score across the top, and then a list of some of the variants down the columns with their functional adjudication on the far right. And so you can see that some variants align on 0, meaning that they had mixed functional properties. Some of them had negative scores, which would tip us to call them loss of function. Others had a more positive score, which means that we would call them gain of function. And also importantly, for most of these variants, we didn't study them once. We studied them twice in 2 different structural forms of SCN2A. One form that's present in the neonatal period and one form that's present after later in childhood and into adulthood. And sometimes we got the same functional result, and other times we got divergent functional results. So it's a complicated functional picture. That said, we went ahead and looked at the relationship between the primary seizure-related phenotype, or whether they had seizures or autism, and what was the composition of the functionality. If you just look at this slide from a distance, you'll see that in the neonatal onset group, there is a preponderance of people who have mixed functional sodium channel variants. Yes, there are some with gain of function. In fact, this is the only category where you see gain of function only. But then there were some that had loss of function as well. So it's really quite more diverse than I think most of us were believing at this point. On the other end of the spectrum, with those with a diagnosis of autism, they all had loss of function to some degree. If we looked at the variant function here with a scatter plot against age of onset, again, if you look just at the neonatal onset group, you can see that there's a clustering of gain and function and mixed function, but there are some where there was loss of function. I want to reiterate that when we did the functional study, we did not know anything about the phenotype. We didn't know the age of onset. We didn't know anything about it. So we were we were blinded to that, and so hopefully as unbiased as possible. On the other end of the spectrum, those with the later onset epilepsies and autism diagnoses, they did tend to be more enriched in loss of function. And that is consistent. Here again, we looked at the variant function versus the severity index, and there wasn't a very strong correlation. All this work has been published recently in the journal Brain, and the author list here is basically my acknowledgments of who did the work. This was mainly led by Ann Berg and her team, and the functional studies were done in my lab, led by Christopher Thompson, and members of the SCN Families SCN2A Foundation were participants in this study. That's the scientific portion of my talk. The other, and the theme here is what you've participated in. Certainly, this study wouldn't have been possible without the participants from the foundation. This is just a group picture of our Center Without Walls as a transition to setting the stage for telling you about something else that was a collaborative effort between the foundation and a number of investigators and other family participants. And this is a book that's been about to be published. That is everything you'd ever want to know and more about SCN2A related disorders. This is part of a series of publications by Cambridge University Press, which is part of their Elements series. They have had these documents, these publications for years in many fields like computational biology and physics and geology, but they've never done one in medicine. And so this was the first. Genetics in Epilepsy was the first foray of this publisher, of this publishing series in a medical specialty. And so this SCN2A related disorders is the second gene-focused installment of the series. Here are all the contributors. Many of these names, many of us are here in the room. These are some thought leaders and doers in the field of SCN2A related disorders. And this is the contents of the book. There's a whole section on the family perspectives, the foundation's history, and also there's many quotes in there, probably from many of you here in the room that were interviewed for this, telling about their stories and their perspectives. Then the more clinical and scientific portions of the book are organized around the clinical phenotype and genotype-phenotype correlations. There's a whole section on the basic science of SCN2A, including its functional effects, invariants, and then a whole section on current and future treatment opportunities in SCN2A. In addition to being a book, there's also online video content, including some interviews with families and key scientists in the field that adds value to the whole work. This is meant to be primarily an online publication, and if it wasn't for a cybersecurity problem with their website, this would have been available now. And you could have used this QR code to go right to the website. Since this slide's only going to be up for a few seconds, I'll call your attention to this small cardboard flyer that's at the registration in the outer room here that has that QR code on the back. And so feel free to grab it. The online edition of this book is free, thanks to investments by the Families SCN2A Foundation to the publisher. And there will be a print version too. Maybe we'll have some copies at the upcoming epilepsy meeting at some point. But anyway, that's all I had to say. Thank you for your participation in our research and listening.